Our first presentation is on the Snake River Bridge emergency repair, beating the odds. Gregg Hostetler from CONSOR Engineering.
Gregg Hostetler, again with CONSOR Engineers. It's good to be here with you all. It's always fun. One of my colleagues was saying, Tom was saying earlier, this is like a reunion every year for us to come back and get to meet with our peers and exchange ideas. So it's a good time, a good opportunity for us to really learn a lot from each other. And so with that, had this really interesting project that I got to be a part of, and I joined the team a little bit late in the game as they had already done an inspection on this Snake River Bridge, and I'll show you the location of this thing here in a minute. But basically this team, our CONSOR had been hired to go in and do an emergency inspection on this bridge, and subsequent to that, we were hired to actually do the repair plans. And subsequent to that, I got on board and actually convinced the owner, the Snake River Sporting Club, to use CMGC. So I don't know is anyone in here familiar with construction manager, general contractor, CMGC as a delivery method? I know some of you are. So a while back, actually I think it was back in 2014, in Orlando, Florida. Some of you guys might recall we had the National Preservation Partnership meeting in Orlando. It was a great time. I know some of you were there. And I had the opportunity to present a concept that at the time I believed very strongly about, and I still do, which is the idea of using CMGC as a method of delivering both emergency bridge repairs as well as just preservation projects, historic bridge rehabilitation projects, which I've done recently in Oklahoma. And so had the opportunity since then to work on a couple of things since 2014 and actually try it out in a meaningful way. And I'm happy to report that it works really well. The method works really well for these projects, largely because you have the opportunity to engage a contractor early in the process. And for anyone who has ever had that opportunity on any type of a project, particularly bridge inspection, or I'm sorry, bridge rehab and repair type projects, you gain a lot of benefits when you have that early contractor input. What I'm going to talk about today is first off just kind of the location and history of this bridge. I'll talk about the incident itself and what kind of damage was caused. Get into some specific challenges that we encountered and some solutions. And finally, what are some key takeaways or lessons learned. The location is, you can see the pin there, it's just south of Jackson. The Snake River Sporting Club is actually a really pretty area. Anyone who's been there knows that it's a fantastic place to vacation. A lot to do there. The sporting club's known for its golf course and some other outdoor activities. Really amazing place. If you zoom in a little further, you can see it a little closer up there just south of Jackson. And then here's an overall aerial view of the bridge. So we start looking at the kind of the configuration of this bridge. It's really interesting. So this thing was relocated. The span, the two long spans, which are the trusses, were relocated to this site in 1999, and then the two shorter spans at the one end were essentially designed and constructed in conjunction with that. So they were newer spans, but the original truss bridges, I don't even know what the original date was when they were originally constructed, but my guess is it was sometime in the 20s based on some of the standards that the DOT was using at the time. What's kind of interesting is when they rebuilt these, they took 4 truss spans, they put 2 of them in this location and 2 of them they put in another location not terribly far away. But when they put these 2 spans in place, they made what were originally 7-panel trusses into a 6-panel and an 8-panel truss. And it seems like something might have gotten lost there in kind of the capacity of these bridges based on that. And then we also came to find out that some of the bottom chords, when they were re-erected, were the wrong size. So some of the bottom chord eye bars were supposed to be 7/8 inch thick, and they were 3/4 of an inch. So you can imagine the impact that also has on your capacity for this bridge. So some major problems there, and I'm going to get into more detail on that here. So June 4th, 2021, this bridge was struck by an overheight vehicle. The clearance on this bridge is only 9 feet and change, I think, so it's a pretty low clearance to start with. So the thing got hit, it pretty much destroyed the portal bracing. The tension forces from that bracing getting hit pulled in the end posts, so they were bent in 2 directions pretty severely. You can see there in the bottom photograph that bidirectional bending that occurred there. So major damage to primary compression element, obviously concerns about buckling. So the bridge was initially shut down. We were able to reopen it several days later after we performed a load rating, but we had to limit it to 6 tons based on that load rating. Some other minor damage occurred to the bridge rails, and that was essentially from the end posts coming in and impacting them. Let's see. We also reduced the speed and restricted traffic to 1 vehicle on the bridge at a time. So some challenges with this. So the bridge owner, this is the first time I don't do much work for private owners. Like most of our work is public. We're working for DOTs and federal agencies, some local governments. This is really the first time in a long time I've worked for a private owner. This owner had no knowledge of what to do with a bridge. And this is at the entrance to their facility. So this thing being out of service has a huge impact on their operation. Not only on the traffic that just comes in and out day to day, but they had major construction projects ongoing. So this owner, we really had to hold their hand. So I came in and served in a role of more of a owner's representative, and then we had other members of our team serving as the design team. Then we actually helped to solicit for and bring on the contractor, the CM/GC entity. So it was a very, very complicated thing because this owner, again, did not have any experience doing these types of projects. There was also an insurance claim that complicated things, and I'll talk about that a little more later, but basically because we were using CMGC, they didn't trust us. Like they wanted bids. Or I kept explaining to them, we're getting good prices here, and this is a fast-paced contract. Like this is the only way we can get this done to meet the timeline of the owner. But we had to go back and forth with the insurance company on numerous occasions to finally get them on board. At a very tight schedule, they wanted this thing reopened prior to the winter weather setting in. Highly technical repairs, which included heat straightening of the truss end posts, complete in-kind replacement of the portal bracing, and then, of course, cleaning and painting of all structural steel that was affected by these repairs. And one of the big challenges also was that we didn't have a really good detour route. We had this poorly maintained maintenance road, which I believe I can show you on the next, actually it might be a couple slides down. But we had a poorly maintained maintenance road that was a private property that they really weren't supposed to be using. So some of the construction vehicles were rerouted to that road for a time, but eventually that property owner lost patience. And that became more problematic. So a lot of constraints, a lot of challenges here. The bottom cords, I think I mentioned this previously, the issue with the I-bars being undersized. And then, of course, the issue with the 7-panel trusses becoming a 6 and an 8-panel. So interestingly, because of those issues, those structural issues, when they re-erected this thing, they had this bridge posted for 38 tons, and I don't know how many years it was posted for that, but it really should have been posted for no more than 27 tons. And that was actually after doing a more kind of refined analysis, sharpening our pencils, like that was the best we could do. So the 38-ton posting was going to have to go away. So ultimately, after we did the emergency repairs, we had to come back and do another project because the owner discovered during this process, we discovered that the bridge needed to have some additional capacity improvements to be able to support the loads that they needed. So again, in addition to having to do the emergency stuff, we came back in for a second phase, which involved strengthening the truss, the center 2 panels of the 8-panel truss. So again, we got really creative on the load rating. We reduced the live load factor, I think, to really low. I don't remember what the number was. We got rid of the impact factor with a speed reduction. We maximized transverse distribution by really restricting where the truck could be on the bridge. And then we even had to go in and say, look, you can bring your concrete trucks across this thing, but you can only bring in 7 yards versus, what do they typically carry, 11, 12? So we had to restrict that as well. So here's the detour that I mentioned. I know it's kind of hard to see here, but if you look at right up here at this Hoback Junction, up here around this Hoback Junction, you have to come across the river in this location and then basically follow the south side of the river all the way down. So, and this whole area down here is poorly maintained. Well, just use your imagination. There's a road that kind of follows the Snake River on the south side there. Yeah, you guys got the point, right? Okay, so alternative contracting. So we looked at, I mentioned earlier that we use CMGC, and I know some of you in the room are familiar with that, but for those that are not, the real point of this presentation is to illustrate the power of using an alternative contracting method for something like an emergency bridge repair. So the technical aspects of this project, which I could talk about for a long time, I'm not going to focus on as much. I'm going to focus more on sort of what CMGC allowed us to do. So for those that aren't familiar, traditionally we produce most projects with what we call design bid build or low bid. And so you see that there on the left. That's where your agency hires a designer and the contractor, but at separate times. You prepare a bid package, you pray that it's correct, and then you put it out to bid and hope for the best, right? So with CMGC, and of course most of you are probably familiar with design build, where you're basically hiring one entity that's the design builder. I'm not going to talk too much about that. That's on the right. But then you've got CMGC, where you're hiring, just like you were with traditional design bid build, you're bringing on the engineer, you're bringing on the CM/GC, but you're bringing them on at the same time. And some agencies do it a little differently. Some do some preliminary design before they make this happen, but the preferred way to do it, according to FHWA, and I actually have the privilege of teaching with FHWA with various state DOTs around the nation. The preferred way is to actually bring all the parties on together, where you have the contractor input from day one. Most of your big ticket cost decisions are during early stages of design. So you want that innovation, you want their perspective on the project before you really do any design. Because frankly, they're going to give you ideas you never would have thought of. And anyone who's had the opportunity to work with a contractor during a design, it's really eye-opening. It's very revealing. So the other party that's sometimes involved in the CMGC process is what we call an ICE, or an independent cost estimator. For this Wyoming project, the Snake River Bridge, we did not have an ICE. Frankly, we didn't have time to get an ICE on board, and we figured we could fulfill that role as the designer. Which, by the way, is not best practice. Designers are not good estimators. I don't know if you guys know that. Designers aren't traditionally estimators. We do our best guess, and then we pray a lot, and we hope for the best, again. So you really need somebody for an ICE. Just for those that are considering using CMGC for projects, you need an independent cost estimator who actually knows how to do what we call bottom-up estimating, production-based, right? Not just picking kind of historic prices, because that gets you so far, but on a project like this, it can be challenging. So anyway, those are the parties that are involved with the CMGC. The idea here is you're all rowing together, you're working on this collaboratively from day one. So you've got your owner calling the shots. The team is following the direction of the owner, or an owner's representative in this case. You've got your designer, your CMGC, in some cases an independent cost estimator. Also your subcontractors, and sometimes even vendors are part of what we call the kickoff meeting, and then the weekly meetings, where really is frankly where the magic happens. That's where you're making design decisions. You have decision makers in the room, you're making quick decisions, and that's why you can turn these projects around so quickly. When you can select your own team, you really have no excuse to fail, right? I mean, with CMGC, you can handpick your whole team based on qualifications. It's absolutely beautiful. I don't know why we haven't been doing this for a long time. So when you get to handpick your team, and you can surround yourself with people you trust and want to work with, it gets really fun for one thing, but also you can really succeed in a way that you've never succeeded before. So in this case, we brought together a really amazing team. Of course, the Snake River Sporting Club was the owner. CONSOR served as an owner's rep as well as the designer. We had Raymond Corp, who served as the general contractor. Dan R. Dalton was the heat straightening component. We had coating specialists for the painting. We had Brand Safeway. They actually came up with an innovative system for a platform for the guys to work on, not for the initial work, but when we had to actually go down underneath to repair the bottom cords to strengthen them, they provided a really neat system for that. And then True North Steel did all of our steel fabrication. When you talk about CMGC, a couple things should immediately come to mind. You're looking for speed. Okay, this is, according to the research done by the University of Colorado Boulder, it is the fastest way to deliver projects. It's even faster than design build. I know there's folks out there that try to argue that, but the data is clear that CMGC is faster. and provides for greater levels of innovation and cost savings. So with this, I'm not going to spend a lot of time on this chart because what's really revealing is this data here, which again is from University of Colorado Boulder, that shows for a typical project, they had a mean, let's see, their project size for DBB was 34 projects, CMGC 10 projects, design build best value 10 projects. And what they found from that sampling was the mean project duration for CMGC is 662 days versus 2130 for design bid build and 1420 for design build best value. That's total project duration. When you look at one of the other columns there, you see 281 days for design and 349 days for construction. So again, this is based on solid research that they did, and so it made it really nice to be able to show actual data instead of saying kind of intuitively we know this, but now we actually have the data. So this proved to be true on this project. Because we had a team, we were able to bring the contractor in. We were able to get moving on some early work packages to start fabricating steel. We were able to have them work with us. We actually had all of these sub-consultants that I showed on the previous slide were coming into our design meetings. They were coming into our pre-construction meetings and actually walking through how to best accomplish this work. So you can imagine as a designer that it's really liberating because now you're not guessing. Now you actually have the experts. We call them specialists, right? You have specialists sitting around the table telling you this is the best way to accomplish this objective. And when you have that, you have something really, really amazing. So if you look here, you can see the schedule. We did abrasive blasting of the steel was accomplished in 2 days, October 21st and 22nd, followed by the heat straightening process, which was 2 days, the 24th and the 25th. By the way, weather was a significant challenge out here, as you can see in one of these images. We had a lot of snow, a lot of really freezing weather out there that made it difficult, particularly for the painting. But here you can see after they've erected the new portal bracing. And then moving on to the truss strengthening. Again, I'm not focusing a whole lot on the technical aspects of this because I really want to focus on the method for delivering this. But you can see the top and bottom cord strengthening, some photographs there, including the work platforms that they used. And here's some more close-up images of the way that we strengthen that bottom cord. So essentially we fabricated a new I-bar type system using a tension rod and actually connected that to the pin between the existing I-bars. So it was a very tight fit. We had to really go out and take some serious measurements to make sure all this was actually going to fit together. But having the fabricator on board to do this made that a lot easier. They were actually able to go out, take measurements, and confirm all of this before starting to fabricate the members. So again, having them on our team made all of this much more possible. The other thing with CMGC that helps a lot, and especially on a project like this where there is a lot of inherent risk, CMGC is the best way to manage risk. And the reason for that is because you're coming together with all the players from day one. So if you think about it, you can retire a lot of risks. You can also account for those risks that can't properly be retired. You can better plan for. You can use allowances and contingencies such that when you build your guaranteed maximum price, all of that stuff is in there. So you're actually giving the best cost certainty to the owner. That owner knows when they get that GMP, that's the most they're going to pay. And chances are it's going to come in under. And in our case, it did come in under. And I know somebody's going to ask me during Q&A what the cost of this project was. And I don't have those final numbers. I tried to get them, but I don't have them. But I will. I have some ballpark numbers. Anyway, CMGC gives the best opportunity to control risk. The other thing is cost control. And again, this is all based on that same research that I mentioned earlier. You have a lot of cost controls here that you don't typically have on a design bid build or a design build. And that's simply because you're able to account for every possible scenario during the design stage because you have all the players sitting around the table. Some key takeaways: CMGC is in fact a valuable tool to deliver emergency bridge repair contracts. The key is you've got to bring the specialist to the table. And I've made the mistake before where we didn't bring a sub, and not having that specialist at the table really kills the opportunity for innovation. I had another project where once we brought the right sub to the table, the minute they were in the meeting, within 10 minutes, they put an idea on the table that saved our team $500,000. So having the right people around the table, having the specialists there is absolutely critical. And then the owner or an owner's representative is key to facilitating. Somebody with CMGC experience to facilitate this process. You can't get the benefits of CMGC if you don't have somebody who kind of has that experience and knowledge of how to do it, right? Selecting the right team members, educating the team on the CMGC process and the benefits that can be derived is really important. You can't get a team excited about doing a thing if they don't understand the process for getting there, right? They have to understand what it is that we can actually accomplish as a team if they're going to be able to do it. And then finally, the insurance claim. For this particular case, and keep this in mind, and those of you that have had bridge hits in particular have dealt with insurance companies, that was the biggest challenge for us. And one thing that we really didn't anticipate going in was that they were going to give us a lot of pushback because of this CMGC method that they weren't familiar with. They just wanted the typical bid process. And we kept telling them, hey, we can't do that here because we can't meet the owner's objectives. There's no way we can get a bid package together, get it out to bid, get the contractor on board, have time to fabricate everything before the winter months set in. So in our opinion, the only way to get this done was to do something innovative like CMGC. So with that, I'll, I think maybe have a little bit of time for a couple questions.
No.
I'll repeat it. How much was the cost? So the initial cost for the emergency repairs, the guaranteed maximum price was $620,000, but that actually included design, all of the construction, included all the contingencies. So we actually brought it in under that. I just don't know what the exact number is that we came under. The second phase is the one that I'm still trying to get the data from the contractor on. So,
Since this was a private company, what was your bidding process? I mean, normally we advertise publicly. Was that did you follow that process to get the qualified contractor?
we did not. We literally handpicked the team. We did a lot of research. We helped the owner. We kind of looked at, first of all, who's available and who has the skill set to perform this work. We kind of did a short list based on that. Very informal. It was all phone calls, reaching out, who can do this work. And then once we got the prime on board, they helped us to line up the subs. So it was very fast. I mean, we didn't have time to do an RFP and get out there and do all of that. There just wasn't time. So it was very much literally just handpicking the best people, the best firms that we thought could do the work.
The final load rating or capacity of the bridge?
After, they wanted to get it back to that 38 tons. So with our final, after we did the strengthening of the upper and lower chords, we were able to get it back to that, which ironically it was never actually at. It was posted for that, but it was not, the strength wasn't actually there.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.